Good morning to all. Today we are going to discuss about servo motor. In last class we discussed about BLDC machine, and in next video we are having an application of BLDC machine, that is sensorless BLDC. Now we are going with an servo motor. The major difference between the servo motor and the stepper motor will be the stepper motor is an open loop control system, whereas your servo motor is an feedback, which is an closed loop control system. The basic definition of your servo machine is servo is an electromagnetic device which having a feedback, that is the negative feedback mechanism which control the electric signal into controlled motion. The servo drive provides precise control over your velocity, acceleration, linear or angular position. So applications like robotic application or some industrial drive application, by using this servo you can able to achieve the closed loop control system. Some of the major types of your servo machines are based on the input power source. It is classified into DC servo machine and AC servo machine. Only thing is, if you are giving DC power, it is said to be DC servo, but the construction of this DC servo and the AC servo will similar to your DC and AC machines. The major construction of the servo machine will have a stator winding, and it will have rotor winding, and it will have an encoder, which is inbuilt sensor used for the feedback control system and used to measure the revolution, and there will be a shaft which is connected with your rotor, which is used for connecting the load, and there will be a bearing which is used for free motion and movement of your shaft. The construction of your circuit will be, the machine will be having a gearing arrangement, which is having a machine that electrical motor may be AC or DC electrical motor, depend upon the application or kind of design, and it will have an outer shaft, and it will have a gear joint, and we are having a different gear arrangements in our system, and inside this the stator and rotor winding will be there. The basic construction of the system will be having the 5 major components like stator winding, rotor winding, bearing, shaft, and the sensor encoder. And the block diagram of your servo machine is, we are having a coil which is a stator coil, where you are going to make your DC supply given to your coil. We are having an applied control which is a predefined value which is going to compare with your system, and the feedback signal which you received from your encoder of the system, and it is sent to your error detector, which is a comparator, where the actual signal is compared with your predefined signal, and the error generation will be happen. That error signal is going to give to your amplifier, where the error signal is amplified, and that amplified output is given to your controller. This controller, either it may be an Arduino or microcontroller, depend upon your application, and this controller will compare the amplified output error signal. Based upon that and depend upon your application, it is going to generate an pulses, and with respect to the pulses, and your machine is going to get input from the system, and thus your coil will get energized. And this is the basic construction of the system. Now we are going with a different speed control operations. Why? Because your DC servo machines are normally widely used in all the applications. This DC servo machines will have similar properties as like your shunt or series DC machines. So the major speed control technique of your machine will have a field control and armature control. So here first control is field control, where the field flux or field current is controlled by using some amplifying signals, that is your error signals are compared. That kind of amplification has happened, and based upon this field you are going to create a speed variation or control the torque across your armature side. By using that you can able to control the overall operation, where in your armature side you are going to make your current component constant, and here you are going to increase or decrease the field current or field flux by using some variable resistance. By doing so, your torque is directly proportional to your field flux. By doing so, with irrespective to your load, you can able to vary the torque. Indirectly you are going to control the speed of the system. And second one is armature. Similar to that, you are going to make your field constant, and you are going to vary the armature current. By varying the armature current, we came to know that your torque is proportional to phi Ia. By varying the armature current, you can able to control the torque in your system. So in this also, you are able to vary the torque. Indirectly, you are going to control the speed of your machine. And the last one is widely used in your servo machine, which is an PID based control technique. First thing, in PID, we already know it is a proportional integral derivative. That is, all the integral and derivative components of all the variables can be considered in the system to get a better precise output from your servo machine. For that, we are going to have a profile generator where we are going to control many parameters like position, velocity, torque, and we are having a current, voltage, all the parameters. For all that, we are using some DC servo motor, and we are having a feedback system from collected from your sensor, and from that it is going to given to your velocity control operation, and it is going to give the displacement change operation or position operation. Depend upon the application, all the signals are received from the system, and by using this PID controller, the total system will vary the position and velocity with respect to current and voltage control command, and that is given to your DC machine. The simple explanation by this block diagram is, we are having a reference value and we are having a PID controller where it is having a proportional integral parameter and also the derivative parameter, and that signal which it received from the motor for each step is collected from your encoder, which is sent to your comparator, or which is sent to your error generator signal. There the position command signal and the feedback signals are compared, and the error signal are amplified, which is sent to the PID controller, and that PID controller which is going to control the motor operation. And some of the major applications of your DC machines are your DC servo machine, which is a feedback control system. So it is widely used in inkjet printers or RC helicopters, and to drive the conveyors used in the industrial manufacturing or some CNC machine applications, we are preferring this DC servo. And it is also used in solar tracking. Mostly in low cost applications, we are preferring stepper motor for solar tracking or solar angle controlling system. We can also prefer some servo system also. And the DC servo machines are widely used in robots, toy cars, and some 3D printers also. It is also widely used in radar, computers, machine tools, tracking system, process controller, and so on. Thank you.